Right, these are the notes for starting 7-1, which is law of sines. So you'll see right here in the green box, this is the law of sines. Law of sines is used when you encounter what we call an oblique triangle. That would be any triangle that's not a right triangle. So it doesn't matter if it's obtuse or if it's an acute triangle, it doesn't matter. If it is not a right triangle, then the law of sines can be applied. So all of the trig that we've done up to this point has been right triangle trigonometry. But starting here with law of sines, we can use trigonometry with triangles that are not right triangles. So the first part of this chapter is usually dedicated to deriving this formula so that you can see how these oblique triangles come from the right triangles. But because of the shortened time that we have, the week that was taken off, we're not going to do that part. We're just going to start right with the law of sines. Just suffice it to say that somebody figured out that this will work with a triangle that's not a right triangle. So notice that it can be written A over sine A equals B over sine B. It could be A over sine A equals C over sine C, B over sine B. So a lot of times they will write it like this. Now, the other thing is it can also be flipped over. You know, it doesn't matter if you have sine A over A equals sine B over B and then sine C over C. So this is a good note for you to follow. When you are using law of sines, it is a good strategy to select a form where your unknown is in the numerator. That just makes the math a little bit easier for you. So just be flexible with the way you write this. It doesn't matter which is on top. If it's the side that's on top, so remember the lowercase letters are the sides, the uppercase letters are the angles. Doesn't matter if the side's on top or the angle's on top, but if you'll put your unknown on top, it makes the computation a little bit easier, the algebra part of it. So let's do an example. So what we're going to do, and I'll do each example separately so you can watch it, but we'll do an example of each kind. If you think back to geometry where you were doing congruency of triangles and you had side angle side or side angle or whatever, this is kind of going to be like that. We're going to look at different ways that we can have known pieces of a triangle and then find the other unknowns. So whenever it says solve the triangle, it means find all of the pieces that you don't already have. So they've given me these. Anytime they give you pieces to a triangle, the easiest thing I think to do first is to draw the picture. And I did not want to do that. So you're just going to draw a triangle. And because I can, and I'm on a, all right, so I'm going to use an actual triangle so that I don't have to sit here and draw one with my weird pen and it would come out weird. All right, so I'm going to label this. All right. So I'm going to, oh, why won't it let me? All right, okay, good, we're good. Yes, there we go. Okay, let me, great. All right. So now it says A is 32, so we'll say this is A. B is 81.8, and I know little a. Now remember, side A is across from the angle, so this is 42.9 centimeters. So I know angle A, I know angle B. I'm going to have to find little b, little c, and big C. So first thing, let's just find big C because that's easy enough. We just do 180 minus 32 minus, so 180 minus 32 minus 81.8 is going to give me big C. So angle C is 66.2. All right, so now I have all my angles. So now let's use law of sines. You're always going to have one known completed ratio. And let's find little b next. So I'm looking for little b, which means I want my little b on top. So little b on top, sine b on bottom. So sine of 81.8 on bottom equals, and the known ratio that I have is 42.9. So the sides are on top right now, over sine 32. Now, it's easiest, I think, to go ahead and do all of the algebra first before you put anything into your calculator, because sometimes they're going to want exact answers. So we are going to do a little bit of middle school math, cross multiply, and I get 42.9 centimeters times sine 81.8 equals b sine 32. And then the next step would be to divide by sine 32. Now, if they ask you for an exact answer, this would be it, because you're going to get a decimal answer when you put this in your calculator. So your exact answer would be this whole thing. And I think sometimes in MyLabs Plus, it will ask you for that. But we want to get our actual answer here. So let me pull up the calculator and share that with you. All right, here's our calculator. Let me clear that. And we're going to plug in I don't know why it made me big. I don't want to be big. I want to be small. Ooh, there we go. Okay. So I'm going to plug all of that in, 42.9 sine 81 over 8. So alpha y equals 1. 42.9 sine 81.8. And I have a feeling that my calculator is not in degrees. So before I hit enter, I'm going to go check that. Sine 32. Load. That's what I thought. So because this problem is in degrees, make sure your calculator's in degrees. And hit enter. And I get 80.128. And that is my answer for the side length of B. So B equals 80.128. Now, if you think about it, that makes sense. So centimeters. So if you think about it, that makes sense. B is a large angle, and so little b, the side of B, is going to be a larger side than side A. So now I still need little c. So I have big C, little b, and I need little c. So I'm going to use law of sines again. And I can either use the known ratio that I was given. I can use A again, or this time I know B, so I could use B. So it's little c over sine c equals, let's go ahead and just use the ratio that we were given, just because that's the one. If for some reason we made some sort of mistake when we found one, this would keep us from using a mistake. Oh, sine c, and I know C is 66.2, so let me put that down here. Okay, so again, we're going to use, we're going to do all our algebra first. So cross multiply. So I get 42.9 sine 66.2 equals C sine 32, and then divide by sine of 32. So this is the exact answer for C. Let's go ahead and plug it into our calculator. .9 sine 66.2 over sine 32. So the side 74 is, the side C is 74.07. So C So there's my two sides, and there was my missing angle. So that means I've solved the triangle because I got all of the missing pieces. So that is it for this example, and I will do more examples on the next one.